The init method is the mechanism that allows every individual object to possess its own unique data the moment it is created. While objects are independent, they require a structured way to initialize their specific information. In Python, this init is a special method that executes automatically at the exact moment a new object is instantiated. It functions as a setup wizard. As soon as Python allocates memory for an object like this one, the init method triggers to populate that object with its own personal data. This ensures that every object starts its life cycle with the necessary attributes already in place. To understand how this works, consider the process of registering at a hospital. When a person enters a hospital for the first time, they are provided with a blank registration form asking for specific details like name, age, and blood group. The moment that form is filled out and submitted, it becomes a personal record. This record is completely unique to that individual. No two patients share the same physical form, even if the blank template was identical. In this programming scenario, the init method acts as the registration form itself. When a new object is born or created in the code, like when we say p equals person, Python automatically fills in this form, giving the object its own copy of data that stays with it. Now, let's explore the key concept of self. The term self is a fundamental requirement in Python classes that represents the specific object currently being processed. When the code defines self.name equals name, it is a command to store a specific piece of data inside the current object only, rather than in some general location. A helpful way to visualize this is through the concept of a name tag. If self is viewed as the name tag itself, then self.name refers specifically to the name written on the tag of the person wearing it, just like Arun's tag here. It distinguishes this object from every other object created from the same class, allowing each to hold their own unique data. As we move forward, we will see exactly how Python manages this memory behind the scenes to keep these entities distinct. The way Python handles memory involves creating separate storage spaces for each object you create. Looking at the first section here, notice how the init method runs automatically to branch out into two entirely distinct entities. On the left side, we have Agent 1, identified as Arjun from Bengaluru. He has his very own set of variables, his agent ID, his name, and his city. Meanwhile, on the right side, we have Agent 2, identified as Sneha from Mumbai. Her variables are completely separate. Now, both objects do share the same starting logic, like self.isAvailable being set to true and orders delivered starting at 0. However, they are completely independent filing cabinets in the computer's memory. As this note emphasizes, changing a value in Agent 1 does not affect Agent 2. In a professional application, this concept allows for massive scale. For example, every time a delivery partner logs into the app, the system immediately creates a delivery agent object. The initialization automatically stores that specific partner's ID, name, and city, and sets their availability to true. Because every single agent is an independent object, the system can track 50,000 agents simultaneously without their data ever getting mixed up. Let's look at how this logic is actually implemented in code down below. It all starts with the template where class delivery agent establishes the blueprint. Inside this class, we define the def init self agent ID name city method. Here, self is the first parameter because it represents the exact specific agent being created at that moment. The next few lines take the information provided during creation and lock it safely inside the object. After that, default values are set for availability and orders delivered. These lines don't need any external input. Every single new agent starts with these exact default values. Later, if we use the show profile method, it retrieves the data belonging only to the agent that called the method. Let's trace the execution. When the code runs agent 1 equals delivery agent, Python automatically calls init for agent 1. When we execute agent 2 equals delivery agent, it makes a separate call to init for agent 2. To definitively prove they are independent, the code executes agent1 dot is available equals false. When we print their statuses afterward, agent1 returns false exactly as we commanded, while agent2 remains true. Modifying one object has absolutely no impact on the other. To quickly reinforce what we've learned, let's consider 3 questions. First, if the init method is omitted, you can still create objects, but they will be empty at birth without any instance variables assigned. Second, what does self represent? It represents the instance of the object itself, ensuring the method knows exactly which object's data to access. Third, if you are building a shipment class for a supply chain app, 5 potential instance variables could be things like the shipment ID, destination, weight, carrier name, and estimated delivery date. The ultimate payoff for understanding these concepts is your ability to build highly structured, scalable systems. For practice, try constructing a product class for an e-commerce platform. Make sure your initialization method can accept product ID, name, price, and stock. You can then add an isStock method to check if the inventory is greater than 0. If you test this by creating 3 different products and changing one stock level to 0, you will clearly see the true power of independent object states. Building objects this way gives you total control over complex data.